The origin of the universe. The universe is vast, stretching across realms that our minds can barely comprehend. Yet, a staggering thought lingers. Everything we see, from the tiniest particles to the most distant galaxies, came from a single moment in time. This moment, known as the Big Bang, happened around 13.8 billion years ago. But what exactly triggered this incredible burst of energy and matter? To grasp the origin of the universe, we must first consider the nature of existence itself. Everything we know, time, space, and matter, sprang into life from an unimaginable singularity. This point was so dense and hot that the laws of physics as we know them seemed to fade away. It raises a profound question: how can something emerge from nothing? As we delve deeper, we encounter the mysteries of cosmic inflation, a theory suggesting that the universe expanded faster than the speed of light in the moments right after the Big Bang. This rapid growth laid the groundwork for galaxies, stars, and planets. But if the universe expanded so quickly, where did all that energy come from? Think about it. There are more stars in the universe than grains of sand on all the beaches of Earth. Yet, despite the vastness of it all, scientists have found that we can only see about 5% of the universe. The remaining 95% is made up of dark matter and dark energy. These elusive forces are the universe's hidden players, shaping its structure and expansion. Why is it that we are surrounded by mystery, with so much left to uncover? As researchers peer into the depths of space, they are also looking back in time. The light from distant stars takes millions of years to reach us, meaning we are observing the universe as it was long ago. This fascinating perspective opens a window to the past, but it also leads to questions about our future. If the universe is expanding, will it continue forever, or will it one day collapse back in on itself? Many scientists ponder the idea of multiverses, other universes existing parallel to ours. If true, this suggests that our universe might just be one of countless others, each with its own unique laws of physics and possibilities. The thought is both exhilarating and humbling. Ultimately, the origin of the universe remains one of science's greatest questions, a puzzle that invites us to explore the unknown. As we stand on the brink of discovery, we must ask ourselves, what does it mean to exist in a universe filled with so many unanswered mysteries? What might we learn about ourselves as we seek to uncover the secrets of our cosmic beginnings? The journey into the heart of existence is just beginning, and the path ahead is as vast as the universe itself. The nature of dark matter. In the vastness of the universe, there exists a mysterious substance that makes up nearly 27% of everything around us. Yet, we cannot see it, touch it, or even directly measure it. This is dark matter, a name given to something that has eluded our understanding for decades. While we can observe the effects of dark matter on galaxies and cosmic structures, its true nature remains one of the most perplexing puzzles in modern science. When we look at the night sky, the stars we see are just a fraction of what exists in our universe. The way galaxies spin and hold together suggests there is more to them than meets the eye. Scientists have noticed that galaxies rotate much faster than they should, based on the visible matter they contain. This discrepancy leads to a compelling question: what is holding these galaxies together? The answer seems to lie in dark matter, an invisible force that exerts gravity without emitting light. Despite being a cornerstone of our understanding of the cosmos, dark matter is not something we can easily grasp. Traditional methods of discovery, those that rely on sight or touch, fail us here. Instead, we must rely on indirect evidence, leading to a fascinating contradiction. We know dark matter exists because of its influence on visible matter, yet we cannot identify what it really is. Some scientists propose it could be made of exotic particles, while others suggest it might even be linked to dimensions beyond our own. This enigmatic material challenges our perception of reality. It invites us to reconsider what we believe about the universe. If so much of it is invisible and unknown, what else lies beyond our comprehension? It's a humbling thought that even in an age of advanced technology and brilliant minds, the majority of matter in the universe remains a mystery. As research continues, scientists are devising innovative experiments to uncover the secrets of dark matter. Some are attempting to create conditions in laboratories that could mimic the cosmic environment, while others are launching satellites designed to detect dark matter's subtle effects. Yet, the more we search, the more questions arise. Why is dark matter so elusive? What might it reveal about the very fabric of our universe? This pursuit of understanding dark matter reflects a deeper truth about humanity's quest for knowledge. We may never fully grasp all the complexities of the cosmos, but it is in this exploration that we find our greatest inspiration. Every unanswered question is an invitation to explore, to think, and to dream. As you consider the vast unknowns of dark matter, ask yourself, what other mysteries might be waiting to be discovered in the universe, just beyond our reach? The mystery of dark energy. The universe is expanding, and it's doing so at an accelerating pace. This means that galaxies are not just moving away from us, they're speeding up as they go. Strange as it sounds, this expansion is driven by something we can't see or touch, something that makes up about 68% of the entire universe. Scientists call it dark energy, but its true nature remains one of the biggest mysteries in science. Picture the vastness of space, filled with millions of galaxies, stars, and planets. Now, think about what's really out there. Most of what we see when we look up at the night sky is just a tiny fraction of what exists. The rest? It's an unseen force pushing everything apart. This force is not just a little nudge, it's a powerful energy that influences the very structure of the cosmos. What makes dark energy even more perplexing is that we know so little about it. We can measure its effects, but we can't directly observe it. Scientists have tried to understand it in countless ways. Some theories suggest it could be a property of space itself, while others propose it might be a new kind of energy or even a modification to our understanding of gravity. Each possibility leads us deeper into a web of questions. Consider how we've constructed our understanding of the universe. For centuries, we believed in a static cosmos, only to discover that it's dynamic and ever-changing. With dark energy, we face another challenge. It's as if the universe is telling us there are rules we don't yet understand. The more we learn, the more it feels like we're just scratching the surface. Here's the surprising twist. Dark energy may not be what we think it is. Some scientists propose that it could be a sign that our understanding of physics is incomplete. What if this unseen force is not just a mystery to be solved, but a hint that there are fundamental truths about the universe waiting to be uncovered? It challenges everything we know and pushes us to reconsider our assumptions about reality. As we ponder the implications of dark energy, we're reminded of the limits of human knowledge. The universe is vast, and our understanding is but a flicker in its expansive timeline. The questions surrounding dark energy open up a realm of possibilities that ignite curiosity and inspire exploration. What if the mysteries of dark energy serve as a mirror, reflecting our own quest for knowledge? How do we approach the unknown in our lives, and what can we learn from the things that elude our grasp? In a world filled with questions, the pursuit of understanding itself becomes a journey worth taking. Perhaps the greatest mystery is not just what dark energy is, but how it invites us to embrace the unknown. Are we alone in the universe? In 1977, a scientist at Ohio State University recorded a signal from space so powerful and unusual that it sparked excitement across the scientific community. It lasted 72 seconds and was never heard again. This mysterious burst, known as the "wow" signal, became emblematic of our quest to answer one of humanity's most profound questions. Are we alone in the universe? As we gaze into the night sky, the vastness stretches endlessly. There are more stars in the universe than grains of sand on all the beaches of Earth. Each star could potentially host a system of planets, many of which may have the right conditions for life. Yet, despite the billions of possibilities, we have not found definitive proof of extraterrestrial life. This paradox leaves us pondering our place in the cosmos. Consider this. Throughout history, humans have always looked to the stars with wonder. Ancient civilizations crafted stories and myths about gods residing in the heavens, While modern science seeks to uncover the mysteries of existence through observation and exploration, we send probes to distant planets and listen for signals, driven by an insatiable curiosity. But in this age of technological marvel, our search for life beyond Earth has yielded silence. The search for extraterrestrial intelligence, or SETI, has been underway for decades, yet we still have no clear answers. Some scientists propose that intelligent life is exceedingly rare, perhaps due to the unique conditions required for it to emerge. Others suggest that advanced civilizations might be out there, but they are either too far away or are deliberately avoiding us. This idea challenges our assumptions about technology and communication. What if the most advanced beings in the universe choose not to reveal themselves? Additionally, consider the possibility that the universe is teeming with life, but it is not life as we know it. Microbial organisms could exist in the clouds of Venus or beneath the icy crust of Europa, one of Jupiter's moons. These forms of life might not resemble our own, yet they spark wonder about the diversity of existence. As we reflect on these questions, it's essential to recognize that the pursuit of knowledge is not solely about finding answers. Each query leads us deeper into the fabric of understanding what it means to be human. Perhaps the most significant aspect of our search for life beyond Earth is the insight it offers into ourselves. So, as we continue to explore the cosmos, let's not only look outward but also inward. What does our longing for companionship in the universe reveal about our own existence? Are we truly alone, or is the answer more complex than we can fathom? The quantum measurement problem. In the realm of tiny particles, things behave in ways that challenge our everyday understanding of reality. Take a moment to consider this. When scientists observe an electron, the act of measuring it seems to change its behavior. It's almost as if the very act of looking at a particle forces it to choose a state, rather than existing in all its potential states at once. This strange occurrence is at the heart of what scientists call the quantum measurement problem, a puzzle that has baffled thinkers for decades. At the core of quantum mechanics, particles can exist in multiple states or positions simultaneously. This idea is known as superposition. Picture a coin spinning in the air. It's not just heads or tails, it's both at once until it lands. However, once we measure or observe that coin, it inevitably falls into one of those states. In the quantum world, this transition from many possibilities to one definitive outcome raises profound questions about the nature of reality itself. What exactly happens during measurement? Why does a particle suddenly decide to be in a specific place or state when observed? Some interpretations suggest that consciousness plays a role, that our awareness somehow collapses these multiple possibilities into a single reality. Others argue that measurement is just a natural part of the universe, independent of human observation. This divergence of views leaves us pondering, is reality a tapestry woven from countless possibilities, or is it a strict, linear path determined by measurement? As researchers delve deeper, they encounter stark contradictions. For instance, two particles can become entangled, meaning the state of one instantly influences the state of another, regardless of the distance between them. This strange connection seems to defy the limits of space and time, leaving us with questions not just about measurement, but about the fundamental fabric of the universe itself. Moreover, the quantum measurement problem isn't merely an academic exercise. It touches on the very essence of how we understand existence. If our observation alters reality, what does that say about our role in the universe? Are we mere spectators, or do our thoughts and perceptions actively shape the world around us? As we ponder these questions, it's essential to embrace the mystery rather than seek a definitive answer. The beauty of science often lies not in conclusions but in exploration. Each question leads us further down a rabbit hole of wonder, igniting the spark of curiosity. So as you reflect on the quantum measurement problem, consider this. What does it mean for you, living in a world where the act of observing could change the very nature of reality? What implications does that hold for how you view your own existence and the choices you make? The fine-tuning of the cosmos. From the tiniest particles to the vastness of galaxies, the universe exists in a delicate balance. It's a balance so precise that even the slightest change could mean the difference between life and lifelessness. Picture this. If the force of gravity were just a tiny bit stronger or weaker, stars might not form at all, or they could burn out far too quickly. The universe we inhabit is meticulously tuned, like a finely crafted instrument, enabling everything from the birth of stars to the emergence of life itself. This raises a profound question. Why is it so perfectly aligned? Scientists have observed that many fundamental forces and constants of nature are set at values that allow the universe to support life as we know it. If these constants were altered, the universe might be unrecognizable, potentially devoid of planets, atoms, or even the basic structures that allow for existence. Consider the strength of the electromagnetic force, which binds electrons to atomic nuclei. If it were slightly weaker, atoms could not hold together, and the chemistry necessary for life would simply not occur. Similarly, the strong nuclear force binds protons and neutrons in the atomic nucleus. Change its strength by even a fraction, and the universe would be a very different place, possibly filled only with hydrogen. The incredible precision invites curiosity, yet it also presents a mystery. Some scientists suggest that our universe is just one of many, part of a multiverse, where different laws of physics might apply. In this scenario, we're simply lucky to be in a universe that supports life. Others argue that the fine-tuning points to a deeper purpose or design, suggesting that perhaps our existence is not just a cosmic accident. As you contemplate the vastness of the cosmos, consider the implications of this fine-tuning. The universe appears to be tailored for us, yet the reasons remain elusive. Is it merely a coincidence? Or is there a larger narrative at play that we have yet to uncover? The contradictions in exploring these questions can be unsettling. On one hand, the universe seems indifferent and chaotic. On the other, it is exquisitely designed. This duality invites a profound reflection. What does it mean to exist in a universe that feels both random and intentional? As you ponder this, think about your place in this finely tuned cosmos. Are we here by chance, or is there something more profound woven into the fabric of reality? The questions linger, waiting for you to explore deeper. The arrow of time. In a world filled with constant change, one of the most perplexing mysteries remains. Time only moves forward. Picture a glass that shatters on the floor. Once broken, it cannot spontaneously reassemble itself. This simple observation forms the basis of what scientists call the arrow of time. It raises a haunting question. Why does time have a direction? At first glance, the idea that time flows only in one direction might seem obvious. After all, we wake up in the morning and watch the sun set, marking the end of a day. We celebrate birthdays that come once a year, and as we age, the past becomes a collection of memories, while the future remains uncertain and uncharted. Yet, when we think deeper, the nature of time becomes less clear. Physical laws, such as those governing motion and energy, are often symmetrical. They can work the same way whether time moves forward or backward. If you were to rewind a video of a glass falling, it would seem just as plausible to see it bounce back together as it would to watch it break apart. So why do we experience time as a relentless march forward? The concept of entropy plays a crucial role in our understanding of time. Entropy refers to the amount of disorder or randomness in a system. In simple terms, things naturally tend to become more disordered over time. Think of a neatly arranged bedroom that gradually becomes messy. The disorder increases, and that reflects a rise in entropy. This irreversible process gives time its direction, moving from order to disorder. However, there's a twist in this understanding. If the universe began in a state of perfect order during the Big Bang, how is it that we find ourselves in a world filled with chaos today? The initial conditions of our universe may hold the key, suggesting that the past was far less chaotic than our present. This notion flips our perspective. Instead of time simply moving forward, it may be that our experience of time is deeply tied to the universe's journey from order to disorder. Yet, as we navigate through life, we create meaning from our experiences, often reminiscing about the past while building hopes for the future. This complex emotional tapestry adds a layer of richness to our understanding of time, suggesting it is not merely a physical phenomenon, but also a deeply personal one. As we ponder the nature of time, we are left with an intriguing thought. If our perception of time is shaped by the universe's chaos, what does that imply about our memories, our choices, and the very essence of our existence? How does the arrow of time influence the way we live and the legacies we leave behind? The limits of human consciousness. In a world where we have mapped the human genome and explored the depths of the ocean, one fact stands out: we still don't fully understand consciousness. It's an extraordinary part of being human, yet it remains shrouded in mystery. Each day, we navigate our thoughts, feelings, and perceptions, but what is actually happening in our minds? Despite incredible advances in science, the essence of consciousness eludes us. Picture the vastness of the universe, billions of stars, galaxies, and countless mysteries yet to be uncovered. Now, consider that within our own minds lies a universe equally as complex. Consciousness is a collection of thoughts, emotions, and experiences, yet we struggle to define it. How do we know we are aware? What does it mean to truly experience something? Scientists have developed theories, ranging from the idea that consciousness arises from brain activity to the possibility that it is a fundamental aspect of the universe itself. Some suggest that consciousness is like a light illuminating a dark room, revealing what we perceive as reality. But here's the intriguing part: each person's light shines differently. Our experiences shape our understanding, and what is vivid and clear for one might be dim and obscured for another. Consider this: the brain is made up of approximately 86 billion neurons, each connecting in unique ways. This intricate web creates our individual consciousness. Yet, despite this complexity, the question remains: why do we even need consciousness? Is it merely a byproduct of evolution, or does it serve a deeper purpose? Many researchers argue that consciousness is a tool for survival, allowing us to reflect on our experiences and make decisions based on past learning. Others believe it's a window into a more profound reality, hinting at connections beyond our daily lives. If our consciousness can stretch and adapt, could it also transcend physical limitations? There's an unsettling contradiction in our pursuit of understanding. The more we learn about the brain, the more elusive consciousness seems. As we dive into neuroscience, we uncover mechanisms of thought and emotion, yet the question of why we experience consciousness at all remains unanswered. This exploration leads us to a profound realization: the limits of our consciousness might not just be about what we know, but what we are yet to discover. Every thought we have, every moment of awareness, pushes the boundaries of our understanding. So, as you ponder the vastness of consciousness, consider this: what does it mean to be truly aware? Are we merely observers of our thoughts, or could there be something more profound lying beneath the surface? As you reflect on this, allow yourself to embrace the mystery, for it is in the unknown where the greatest insights often emerge. What lies beyond the observable universe? The universe is vast, stretching across billions of light years, yet only a fraction of it is visible to us. In fact, the observable universe is about 93 billion light years in diameter. But here's the mind-boggling part: what lies beyond this immense boundary? It's a question that sparks wonder and curiosity, yet remains one of science's most tantalizing mysteries. As we gaze at the stars, we are looking back in time, witnessing light that started its journey long ago. However, this light has only traveled as far as the observable universe permits. Beyond that, we are left in the dark, unable to see or measure what exists. Some scientists speculate that beyond the observable universe, there might be more galaxies, more stars, and perhaps even more forms of life. But how can they be so sure when we have no direct evidence? The truth is, the universe is constantly expanding. This expansion means that regions of space are moving away from us faster than the speed of light. As they recede, their light is not reaching us, locking them away in a cosmic prison of invisibility. It's a strange paradox. There could be entire worlds, teeming with activity, just out of reach of our perception. Now, consider this: if the universe is infinite, then beyond what we can see, there may be an endless expanse filled with galaxies and phenomena we can't even begin to imagine. Yet, if it's finite, could it end somewhere? And if it does, what lies at that edge? Is it nothingness, or something entirely different, maybe even more dimensions we have yet to comprehend? This brings us to a surprising truth. Our understanding of the universe is limited not just by technology, but by the very nature of reality. We often think of the universe as a whole, but what if it's just a bubble in a larger multiverse? Some theories suggest there could be countless other universes, each with its own set of laws and conditions. This idea challenges our perception of existence itself, raising profound questions about our place in the grand scheme of things. As we ponder these possibilities, we must also confront our own limitations. The human mind is capable of incredible insight, yet it struggles with concepts that defy our everyday experiences. The edge of knowledge is a fascinating boundary, filled with uncertainty and wonder. So, as you reflect on what lies beyond the observable universe, consider this: is our quest for understanding a journey towards enlightenment, or an endless pursuit of questions that may never be answered? What if the true beauty of the universe lies not in its answers, but in the mysteries that inspire us to keep exploring? The true nature of gravity. Have you ever considered that gravity, the force that keeps us grounded, is still one of the biggest mysteries in science? Despite being one of the four fundamental forces of nature, we know surprisingly little about it. For instance, gravity is the reason why an apple falls from a tree, but it's also what keeps the moon in orbit around the Earth and the Earth in orbit around the sun. It shapes our universe and influences everything we experience, yet its true nature remains elusive. Gravity pulls objects together, but what exactly is this force? We often think of it as a simple attraction between masses. However, what if gravity isn't just a force pulling things down? Some scientists believe it might be more complex, perhaps even a result of the way space and time interact. This idea challenges our basic understanding. Instead of seeing gravity as merely a force, we could think of it as a curvature in the fabric of space itself. This perspective suggests that massive objects like planets and stars warp the space around them, causing other objects to move along these curves, but that leads to more questions than answers. Consider this: if gravity can bend space, could it also be influencing time? Some theories propose that time moves slower in stronger gravitational fields. This means that if you were to stand at the bottom of a mountain, time would pass differently for you than for someone at the top. It's a mind-bending thought, isn't it? Yet, while we have these intriguing theories, we still lack a complete understanding of why gravity behaves the way it does. Moreover, there's a fascinating contradiction in gravity. It's incredibly strong on a large scale, holding galaxies together, yet it's also the weakest of the four fundamental forces. In fact, if you were to compare it to electromagnetism, gravity would lose by a landslide. So why, in a universe governed by such powerful forces, does gravity maintain its role as the glue that binds everything? This counterintuitive nature leaves us pondering. As we look further into the universe, we encounter dark matter and dark energy, both of which are believed to interact with gravity. But we have yet to see them directly. Instead, we observe their effects, which raises even more questions. What are these unseen forces? How do they relate to the gravity we can observe? Ultimately, gravity remains a window into the mysteries of our universe. It invites us to reflect on what we know and what we still have to discover. Perhaps the most profound question we can ask ourselves is this: in a universe filled with so many unknowns, what does our understanding of gravity reveal about our place within it? The Puzzle of Antimatter. In the vast universe, there exists a mysterious substance that is almost like a ghost. It's called antimatter, and it behaves in ways that challenge everything we think we know about reality. In fact, if you gathered all the antimatter produced in a year, it would weigh less than a grain of sand. Yet, this tiny amount holds the key to some of science's biggest mysteries. Antimatter is like a mirror reflecting our universe, but with a twist. For every particle of matter, like the atoms that make up our bodies, there is a corresponding particle of antimatter. These particles are almost identical, but they have opposite charges. When they meet, they annihilate each other in a burst of energy. This reaction is so powerful that it gives us insight into the fundamental forces of nature. But here's the real puzzle. Our universe is overwhelmingly filled with matter, while antimatter is nearly absent. Scientists have been grappling with this imbalance for decades. Why did the universe favor matter over antimatter? Some theories suggest that during the Big Bang, the conditions were just right for a tiny excess of matter to form. But the details remain elusive, leaving us with more questions than answers. Imagine a world where antimatter was as abundant as matter. If we could harness it, we could create energy in ways we can barely conceive. A small amount could fuel entire cities, or even power spaceships for journeys across the stars. Yet, here we are, barely managing to detect minute amounts in labs, while the cosmos seems to operate on a different set of rules. Another thought-provoking contradiction arises when we consider how antimatter behaves. In our world, we perceive time as linear, moving from past to present to future. Antimatter, however, can challenge those perceptions. Some scientists propose that antimatter could be time running backward. It's a radical idea that makes us question not just the nature of particles, but the very flow of time itself. As we delve deeper into the mystery of antimatter, we encounter more questions. What secrets does it hold about the origin of the universe? Could it reveal hidden dimensions or lead us to new physics beyond our current understanding? The vastness of these inquiries can feel overwhelming, yet they inspire a sense of wonder. The universe is a puzzle with pieces still scattered, and antimatter is one of the most intriguing pieces. As you ponder this enigma, consider how little we truly understand. What does the absence of antimatter say about our existence? Could it be that the answers we seek are not just about the stars, but about us? The emergence of life from non-life. Picture a world more than 4 billion years ago where there was no life, just a barren landscape of rocks and swirling gases. Yet somehow, amid this lifelessness, the seeds of life began to sprout. Scientists have long pondered how inanimate matter transformed into living organisms. It's a mystery that continues to capture our imagination. Consider the conditions on early Earth, a mix of water, volcanic activity, and a rich brew of chemicals. These elements played a crucial role, creating an environment that allowed for complex reactions. But here lies the central question: how did simple molecules band together to form the first cells? What sparked the transition from lifeless chemicals to something that could grow, reproduce, and adapt? For decades, scientists have proposed various theories. Some suggest that life began in the depths of the ocean, where hydrothermal vents provided the necessary heat and energy. Others argue it started on land, in puddles of water, where sunlight could catalyze the reactions needed for life. The exact location is still up for debate, but the essence remains the same: a miraculous transformation. The intriguing part is that even if we could trace back the steps to the emergence of life, we don't fully understand why it happened. Why did these molecules decide to combine and form the building blocks of life? It seems extraordinary that, given the vastness of space and the variety of conditions on other planets, life emerged uniquely on Earth. What is it about our planet that set the stage for such a remarkable event? Many believe that understanding this leap from non-life to life could unlock secrets not just about our origin, but about the potential for life elsewhere in the universe. Yet, even after many experiments and theories, the question remains tantalizingly unanswered. The world of abiogenesis, how life arises from non-living matter, still eludes definitive explanation. This brings us to a fascinating contradiction. While scientists have made tremendous progress in understanding the building blocks of life, the leap from simple molecules to complex organisms feels almost magical. It suggests that there is more to life than mere chemistry. Perhaps there's a hidden blueprint or a spark of creativity that we have yet to comprehend. As we gaze up at the stars, pondering the possibility of life on other planets, we must also reflect on our own beginnings. What does it mean to be alive in a universe that once was devoid of life? As we seek answers to these profound questions, we invite ourselves to wonder about the mystery of existence. Could the emergence of life from non-life be a reminder that the universe holds secrets waiting to be discovered? The hard problem of consciousness. How is it that a lump of tissue weighing just 3 pounds can produce the rich tapestry of thoughts, feelings, and experiences that make up our everyday lives? This is the essence of the hard problem of consciousness, a question that has puzzled scientists and philosophers alike for centuries. While we understand much about the brain's physical structure and its functions, we still grapple with the mystery of how these processes translate into the subjective experience of being aware. The brain is an intricate network of neurons, firing signals and creating connections. We can measure brain waves, identify areas responsible for specific tasks, and even observe the brain in action during various activities. Yet, when we try to understand why these electrical impulses lead to sensations like joy, sadness, or the taste of chocolate, we hit a wall. This is where the hard problem emerges, the challenge of explaining how physical brain processes give rise to our inner world. Consider this: when you see a breathtaking sunset, your eyes detect colors, and your brain processes the information. But what makes that moment beautiful? What transforms a simple visual into a profound experience? This gap between physical reactions and emotional responses is a core aspect of the hard problem. It urges us to explore not just the how, but the why of consciousness. Many scientists propose that understanding consciousness requires a new approach, one that goes beyond traditional methods. They suggest that consciousness might not be something produced by the brain at all, but rather a fundamental aspect of the universe, much like space or time. This perspective challenges our conventional views and invites us to rethink our place within the cosmos. Furthermore, consider the implications if consciousness isn't just a byproduct of brain activity. What does it mean for our understanding of self? If consciousness exists independently, it blurs the lines between our individual experiences and a shared reality. Perhaps our thoughts and feelings are not solely ours, but part of a larger, interconnected fabric of existence. As we delve deeper into the hard problem of consciousness, we find ourselves standing at the edge of a vast and intriguing mystery. The more we explore, the more questions arise. Are we merely biological machines, or is there something more at play? What does it mean to be aware, and how does that awareness shape our understanding of the world around us? In a quest for answers, we often find that the most profound questions remain unanswered. As you reflect on this topic, consider how your own consciousness influences your view of reality. What role does your awareness play in shaping your experiences? The journey into understanding consciousness may not lead to clear answers, but it certainly opens a door to deeper exploration. What mysteries will you uncover on your path of inquiry? The Multiverse Hypothesis. There are more stars in the universe than grains of sand on all the beaches on Earth. Yet, this vast universe may be just one of many. The Multiverse Hypothesis suggests that our universe is just a small part of a far larger reality, a collection of countless universes, each with its own unique properties, laws, and histories. This idea stretches our understanding of existence itself. The multiverse can be difficult to grasp. It challenges the very notion of what we think of as reality. Picture this: every decision you make creates a branching path, leading to different outcomes. In one universe, you might have chosen a different career, while in another, you might be living in a completely different world. Each choice spawns a new universe, representing a different version of you. This means there could be countless yous out there, each exploring different possibilities and experiences. But it gets even more intriguing. Some scientists propose that these universes could be dramatically different from ours. In one universe, the fundamental forces of nature might work differently, leading to entirely different forms of life. In another, the very fabric of time might be woven in a way that time itself behaves unlike anything we know. This raises profound questions about the nature of existence and our place within it. Now, consider the implications of such a vast multiverse. If there are infinite worlds, then the odds of our particular universe being the only one are astronomically low. This forces us to confront a surprising truth: our universe may not be as special as we like to believe. It's a humbling thought, suggesting that we are just one of many possibilities floating in an endless sea of realities. Each universe, with its own unique story, exists alongside ours, just out of reach. This leads us to wonder about the limits of our knowledge. What if there are universes where the laws of physics are completely alien to us? Can we even comprehend the full scope of existence? The multiverse hypothesis does not just challenge our scientific understanding, it invites us to reflect on our own significance in the grand scheme of things. As we ponder these questions, we find ourselves standing at the edge of human understanding, where science meets philosophy. The multiverse opens doors to ideas we have yet to explore, offering a glimpse into the depths of reality that remain mysterious. So, as you sit with these thoughts, consider this. If there are countless universes, what does that mean for our choices and experiences here and now? What does it mean to truly understand our reality if there are so many others out there? The answers are still waiting to be uncovered, inviting you to explore the unknown. The origin of mathematics. Long before humans built civilizations or wrote down their thoughts, there existed something enigmatic and powerful: numbers. They are as old as humanity itself, yet the question remains, where did mathematics come from? This seemingly simple concept is woven into the very fabric of our reality, yet its origins are shrouded in mystery. Picture this: ancient people, standing beneath a vast sky filled with stars, began counting their livestock or measuring the land they walked on. They used their fingers and stones, creating a system to make sense of the world around them. But how did these basic instincts transform into the intricate world of mathematics we know today? Mathematics is not merely a tool for counting, it is a language that describes patterns, relationships, and structures. It helps us understand the universe, from the tiniest particles to the vastness of galaxies. Yet, despite its universal nature, we struggle to pinpoint its true origin. Was it a discovery of the mind, or was it a human invention? Some argue that mathematics is a natural part of our world, existing independently of human thought. This perspective suggests that numbers and equations are out there, waiting to be uncovered, like hidden treasures. Others see it as a creation of human culture, shaped by our needs and experiences. If that's the case, then mathematics is a reflection of our journey, constantly evolving as we learn and grow. As we delve deeper, we encounter a surprising contradiction. While mathematics is a universal language, it is also deeply influenced by culture and history. Different civilizations have approached numbers in unique ways. The ancient Egyptians had their own methods for measuring, while the Mayans developed a complex number system that included zero long before it was common in Europe. Each culture added layers to the mathematical tapestry, yet the core concepts remain strikingly similar. This brings us to a profound truth: mathematics connects us across time and space. It transcends borders and languages, yet we still grapple with its origins. How can something so fundamental remain enigmatic? Perhaps the answer lies not in the facts or formulas, but in the questions themselves. As we contemplate the origins of mathematics, we find ourselves confronting deeper questions. What does it mean to understand the universe? How does our perception shape the numbers we use? The journey of exploring these questions can be as enlightening as the answers we seek. As you ponder the nature of mathematics, consider this: is it a discovery of truth, or a creative expression of human thought? What role do you think mathematics plays in your own understanding of the world? The answers may not be clear, but the quest for knowledge continues. The fate of the universe. What if I told you that everything we see around us, from the tiniest ant to the vastest galaxy, is racing toward an uncertain end? In the grand tapestry of existence, the fate of the universe hangs in a delicate balance, and we are but brief flickers of light in its expansive story. This vast cosmos has been unfolding for billions of years, and yet, we still grapple with questions about its ultimate destiny. As we peer into the night sky, we notice the stars twinkling far beyond our reach. Each star is a sun, and many of them have their own planets, possibly housing life. But what lies ahead for these celestial bodies? Scientists have proposed several scenarios, each more intriguing than the last. Some suggest that the universe will continue to expand forever, drifting into a cold, dark void. In this scenario, galaxies will move farther apart, stars will extinguish, and eventually only black holes may remain, slowly evaporating over trillions of years. Then there's the idea of the Big Crunch. Picture this: the universe, now stretching endlessly, might one day reverse its expansion. Everything could collapse back into a singular point, a cosmic contraction where time and space as we know them cease to exist. It's a dramatic thought, as if the universe itself is holding its breath, waiting for the moment it will pull everything back into its mysterious depths. And what about the concept of a big rip? This hypothesis suggests that the very fabric of the universe could tear itself apart. As the expansion accelerates, it might reach a point where galaxies, stars, and even atoms are ripped from existence. Imagine a universe unraveling like a piece of thread pulled too tight. While these theories paint a picture of endings, they also reflect a deeper truth about our existence. The universe is not merely a backdrop for our lives, it is a living entity, constantly changing and evolving. Each question about its fate invites us to ponder our own place within it. Are we merely observers, or do we play a role in the unfolding narrative? Consider this: as we explore these vast questions, we often find ourselves reflecting on the nature of time, existence, and our interconnectedness. The universe might be an enigma, but our curiosity propels us forward, urging us to seek answers. So, as you look up at the night sky, let this thought linger. What does the fate of the universe mean for you? In a world that feels both vast and intimate, how do you choose to engage with the mysteries that surround us? What questions will you explore as you contemplate your place in this incredible cosmic journey? The limits of artificial intelligence. What happens when we create something that can think, learn, and even evolve? Today, we explore the fascinating yet perplexing world of artificial intelligence, a realm filled with immense potential but also significant limits. Currently, AI powers our lives in ways we often take for granted. From the moment we unlock our smartphones to the time we receive recommendations for our favorite shows, AI is there, quietly shaping our experiences. Yet, there's a captivating truth lurking beneath the surface. Despite its capabilities, AI remains largely dependent on humans. It does not possess understanding or consciousness. It operates based on patterns it has learned from vast amounts of data, but it lacks the ability to truly comprehend or experience the world in a human way. Consider this: while AI can analyze millions of medical records to suggest treatments, it cannot empathize with a patient's fear or hope. It can predict the weather based on historical data, yet it cannot feel the warmth of the sun or the chill of a breeze. This raises profound questions about the nature of intelligence itself. What does it mean to know something? Is knowledge simply the ability to recall information, or is it more about the depth of experience behind that knowledge? As we delve deeper, we encounter another intriguing limitation. AI can perform tasks that require immense precision, such as playing chess or diagnosing illnesses. Yet, it struggles with tasks that seem simple to us, like understanding humor or navigating social interactions. The subtleties of human communication and the richness of emotional nuances are territories AI grapples with, often falling short. This paradox leads us to rethink our assumptions. Is intelligence merely a collection of skills, or does it encompass a broader spectrum of understanding? Now, consider the ethical implications of this reliance on artificial intelligence. In our quest to enhance our lives, are we creating a form of intelligence that could surpass us? The very systems we build might one day lead us to question our own relevance. As we hand over more responsibilities to AI, we must reflect on what we value as uniquely human. Is it our creativity, our emotional depth, our capacity for love and connection? These are aspects of our existence that machines may never replicate. As we stand at this crossroads, we invite a deeper reflection. What does it mean to be intelligent? Are we merely defined by our ability to process information, or is there something profoundly human that cannot be captured by algorithms? The limits of artificial intelligence challenge us to explore our own humanity. In a world increasingly shaped by technology, How will you define intelligence, and what unique qualities do you cherish in yourself that AI may never understand? The mystery of quantum entanglement. Imagine a pair of dice. You roll them, and both come up as sixes, no matter how far apart they are. Now, what if I told you that in the realm of quantum physics, something similar happens with tiny particles? This phenomenon is known as quantum entanglement, and it challenges everything we think we understand about the universe. In the world of quantum mechanics, particles can become entangled in such a way that the state of one particle instantly influences the state of another, regardless of the distance separating them. If one is spinning in a certain direction, the other will mirror that spin, even if it's light years away. This connection seems to defy the very rules of space and time as we know them. To grasp the depth of this mystery, consider how we perceive the world. We rely on the idea that everything is separate, that actions are localized, and that distance matters. Yet, quantum entanglement flips that notion on its head. These particles behave as if they are part of a single, unified system. Disturb one, and the other responds without delay, as if they are communicating across vast emptiness. Researchers have confirmed this strange behavior through experiments, but what remains baffling is how, or even why, this occurs. The implications are staggering. If particles can be so deeply connected, what does that say about the fabric of our reality? Are we all in some fundamental way interconnected? Some scientists suggest that entanglement hints at a deeper layer of reality, a world where our conventional understanding of cause and effect no longer applies. It's like peering into a mirror that reflects not just what we see, but something far more intricate and profound. Yet, the questions linger. If entangled particles can affect each other without any apparent connection, does that mean information can travel faster than light? Or, more intriguingly, could this be a glimpse into a hidden dimension of existence that we have yet to explore? As we ponder these questions, we find ourselves on the brink of understanding something far greater than quantum mechanics alone. The idea that everything might be connected in ways we can hardly conceive opens a door to new perspectives about life, relationships, and our place in the universe. So, as you reflect on the mystery of quantum entanglement, consider this. If the universe is indeed woven together in such an extraordinary manner, how does that change the way we view our own connections with others? Are we all part of a larger tapestry, intertwined in ways we have yet to fully comprehend? The information paradox of black holes. Black holes are among the most mysterious objects in the universe. They are regions in space where gravity is so strong that nothing, not even light, can escape their pull. This means that once something crosses the event horizon, the point of no return, it disappears from our view and knowledge. But here's where it gets really intriguing. According to our current understanding of physics, information about anything that falls into a black hole should be lost forever. This idea seems straightforward, but it leads to a puzzling contradiction that has left scientists scratching their heads. Consider the concept of information. In the realm of physics, information is not just a collection of facts, it's the very essence of the universe's state, a record of what exists. Think of it like a library, where every book represents a piece of information about the world. If a black hole swallows a star, according to traditional views, all the information about that star vanishes. Yet, physics teaches us that information cannot simply disappear. This is where the paradox lies. The tension between these two ideas creates a fascinating dilemma. On one hand, we have black holes, which seem to erase information. On the other, we have the laws of quantum mechanics, which insist that nothing can be truly lost. This conflict raises profound questions. Is our understanding of black holes wrong? Or is there a deeper truth about how the universe operates that we have yet to uncover? Some brilliant minds, like physicist Stephen Hawking, propose that black holes might not erase information entirely. Instead, they suggested that information could be stored on the event horizon, similar to a hologram. This idea hints at a universe that is far more intricate than we can imagine. If information can somehow escape a black hole, it transforms the way we think about reality itself. It challenges our perception of time, space, and existence. Yet, even with these theories, uncertainty remains. The mystery of what truly happens to information inside a black hole continues to haunt scientists. It's as if the universe is hiding a secret, one that may hold the key to understanding the fabric of reality. As we ponder this enigma, it's worth reflecting on how much we still don't know. In a world where answers seem so vital, the existence of questions like this serves as a reminder of our limitations. The cosmos is vast and complex, and perhaps its greatest lessons lie not in certainties, but in the mysteries that provoke our curiosity. What does it mean to truly understand the universe if some of its fundamental truths remain just out of reach? The enigma of time itself. Time is a strange companion in our lives. It flows continuously, yet we often find ourselves caught in its web, struggling to grasp its true nature. Consider this: every moment we experience is like a fleeting whisper, here and gone before we can fully understand it. But what is time really? We measure it in seconds, minutes, and hours, creating schedules and routines based on this invisible thread. We age, our days turn into years, but time itself remains an elusive concept. Scientists have debated its essence for centuries. Is it a physical dimension, similar to space? Or perhaps it's merely a human construct, a way for us to make sense of our experiences? As you sit here, take a moment to reflect on how you perceive time. Does it feel fast or slow? Sometimes it seems to stretch on indefinitely, while at other times it races ahead, almost mocking our attempts to hold on to it. This perception can change based on our emotions or activities. Think about a day filled with joy versus a day filled with dread. The clock ticks the same, yet our experience of time can vary wildly. Consider how time shapes our understanding of the universe. The vastness of space is measured in light years, but what about the time it takes to travel those distances? When we look at the stars, we are not seeing them as they are now, but as they were, sometimes millions of years ago. This distance creates a fascinating paradox. We are witnessing the past, even though we exist in the present. Then there's the concept of time travel. While it remains a staple of science fiction, the idea of moving backward or forward in time raises profound questions. If we could travel to the past, would we change our present? And if we could leap into the future, would the world still feel familiar? This contradiction challenges our understanding of cause and effect, leaving us pondering the consequences of our choices. Now, let's delve deeper. What if time is not linear at all? Some theories suggest that all moments exist simultaneously, past, present, and future intertwined. This idea can be unsettling. It invites us to reconsider our place in the universe. Are we merely observers in a grand tapestry, or do we have the power to weave our own threads into time? As you reflect on these thoughts, consider this: what does time mean to you? Is it a friend guiding your journey, or a foe that slips through your fingers? The mysteries of time remain vast and unsolved, inviting us to explore further. In this exploration, we might just uncover a deeper understanding of ourselves and our existence. The unification of physics. In the vast tapestry of the universe, there lies a mystery that has puzzled the brightest minds for centuries. Picture this: everything we experience, from the tiniest particle to the grandest galaxy, operates under two major forces, gravity and electromagnetism. Yet, these forces don't speak to each other in the way we might expect. It's as if they're two dancers in a grand performance, each moving to their own rhythm, unaware of the other's existence. This separation raises profound questions about the very nature of reality itself. The quest for a unified theory of physics is a journey that has captivated scientists for generations. At the heart of this pursuit is the desire to discover a single framework that can explain all physical phenomena, seamlessly connecting the forces that govern our universe. Current theories, like general relativity, describe gravity with elegance, while quantum mechanics delves into the behavior of particles at an astonishingly small scale. Yet, when we try to merge these two pillars of physics, we encounter a wall of contradiction. How can something as vast as gravity coexist with the strange and unpredictable world of quantum particles? Consider this: The universe is governed by rules, yet these rules seem to shift depending on the scale we are observing. A baseball flying through the air behaves according to classical physics, while a photon of light dances through the cosmos according to quantum mechanics. This inconsistency raises an intriguing thought. What if our understanding of these forces is merely a reflection of our limited perspective? Some scientists believe that in our quest for unification, we may need to rethink the very foundations of how we perceive forces. Could it be that gravity and electromagnetism are not separate entities but rather different manifestations of a single underlying principle? This idea challenges our conventional understanding and invites us to explore the fabric of reality in a new light. As we ponder this, we must confront a startling truth. Our universe is not only stranger than we imagine, it's stranger than we can imagine. What lies beyond our current grasp may hold the key to unlocking the mysteries of existence. The unification of physics is not just a scientific endeavor, it's a philosophical journey that invites us to question our place in the cosmos. So, as you reflect on these ideas, consider this. If the forces of nature can exist in separation, yet still govern our lives, what other truths in our world might be waiting to be discovered, obscured by our own assumptions? In the grand scheme of things, how much do we really understand about the universe we inhabit?